Hello students, let's learn about physical properties of metals and non-metals in this video, that is part 2 video of chapter metals and non-metals. The first property is the physical state. All the metals, they are generally solid at room temperature, whereas all the non-metals the non-metals, it can exist in solid, liquid or gaseous state. There is one metal which is mercury, which is the liquid metal, and the examples for the solid metals are, you can quote any example like iron, copper, aluminium, gold or silver. In non-metals, the example for the solid non-metals is carbon, sulfur, phosphorus and iodine. Liquid, only one liquid non-metal is known, that is bromine. And in gaseous state, we can have the example for chlorine, oxygen and nitrogen. The second property is melting and boiling point. Metals, since they are solids, they have generally high melting and boiling point. Example, the melting point of iron, it is 1536 degrees Celsius, and boiling point is furthermore, that is 3000 degrees Celsius. There is an exception to this. The cesium metal, it can melt in our palm also. The melting point of cesium is so low, 28.7 degrees Celsius. So we can melt it by keeping it in our palm. So the melting point of cesium, which is an exception, is quite low. Whereas non-metals, they have generally low melting point and boiling point as compared to metals. But over here also we have an exception of diamond, which has quite as well as graphite, which are forms of carbon, which have very high melting and boiling point. The third property is density. Metals generally have high density, non-metals have low density. The exception in the metals is the sodium and potassium, which have low density, that they can float over the water. That means their density is less than water. Whereas in non-metals, they have, all of them, they have very low density. Hardness, the fourth property. Metals, they are generally hard, as we know, and the non-metals, they are not so hard as compared to metals. They are considered to be soft, and they are brittle. That means they can easily broken down into pieces when they are hammered. Like in your book, it is an activity which is given, that if you take the iodine crystals and if you hammer them, then these iodine crystals, they will break down into smaller pieces. That means it shows that the non-metals, they are brittle and they can be easily broken down into pieces, and they are not so hard. The fifth property is the luster. Luster, students, means possessing shine. So anything which will possess shine, it means that it possesses luster. All the metals, they possess luster, whereas non-metals, they do not possess luster, so they are non-lustrous and they have a dull appearance. Here also we have an exception of iodine, which is only lustrous metal, non-metal in the category of non-metals. Many students, they do this mistake, that while writing the exception in non-metals, they write down diamond, which is wrong. The sixth property we will talk about is malleability. What is malleability? Malleability is a property in which the metals, they can be hammered into thin sheets without breaking. This is called malleability. Like in your book, the activity 2 says that if we hammer the zinc metal or a zinc granule, on hammering it, we can convert it into a thin sheet without breaking. This shows that the metals, they are malleable, whereas non-metals, they are non-malleable. Therefore, around us, we can see the sheets of iron, we can see the sheets of copper, we can see the sheets of aluminium, which we use for food packaging. The next is ductility. Ductility, it is the property by which the metals, they can be drawn into thin wires without breaking. This property is called ductility. Example, like we can have the copper wires, aluminium wires, iron wires, these all things shows that the metals, they are quite ductile, whereas non-metals, they are non-ductile. That means you cannot draw them into thin wires. They will break down on stretching. The eighth property is the tensile strength. What is a tensile strength? It is the property due to which the material can bear a lot of strain without breaking. That means if you attach something heavy to a material, then that substance will not break. It will hold that heavy substance without breaking. This is called tensile strength. So we know that we use the iron chains or the metallic chains to lift up the heavy materials or the heavy weights. So we can say that the metals, they have high tensile strength, whereas non-metals, they do not have high tensile strength. Here the exception is the carbon fiber, which has quite good tensile strength. The next is the thermal conductivity. What is thermal conductivity? The ability of the material to conduct heat energy from one point to another. As we know that we use the metals in all our kitchen utensils. So this shows that the metals, they are good thermal conductors, which you have read in the 7th standard also. So there is an activity also that if you take a hot water in a beaker and if we put iron rod or any metallic rod into it for some time, and then if we are touching it from the other end, we will find that the other end is also get heated up due to that hot water. This shows that all the metals, they are good thermal conductors, whereas non-metals, they are poor thermal conductors, or they do not conduct thermal or the heat energy from one point to another. The electrical, here also we have exception of diamond, which is a good thermal conductor. Then electrical conductivity, which is the ability to transfer the electric current from one point to another. The metals, we use the metallic wires for electrical fitting. So this shows that the metals, they are good electrical conductors, whereas the non-metals, they are poor electrical conductors, or we can say they are non-conductors or insulators. Here also there is an exception of graphite, which is a form of carbon, which is a very good conductor of electricity and is used in batteries. The activity given in your book is that we can use the testers to check whether the material, it is a good conductor or not. If we are using the tester, which is a battery and a bulb, and if the bulb glows, that means the material is a good conductor. If the bulb is not glowing, that means the material is a bad conductor. Silver is the best conductor of heat and electricity, which is followed by copper and aluminium. And mercury, it is the poorest conductor among the metals. The last property is sonorosity. Sonorosity is a property due to which the metals, they produce sound when they are hammered with something hard. So this is called sonorosity. All the metals, they are used, we know they are used in making bells. So that means all the metals, they are sonorous as they will produce the sound on hitting. Whereas non-metals, they are non-sonorous. So this was all about the physical properties of metals and non-metals. In our next video, we will talk about the chemical properties. Till then, enjoy learning, students. Thanks for watching.